Algebras. Here is our Chapter 8 exam review. I am going to go over a few questions in the exam review so that you understand everything that's going to be a part of your test. Now, remember, all of the exam review questions, there's always more examples in the review for you to practice than there are on the actual test. Okay, this test is a Google Forms test, so you are going to want to use your white assessments packet to show your work and take a picture of that and upload it with your Google form. But these are the types of questions you're going to run into. So as I go through the questions that I'm going to go over, and I'll leave you examples to then try on your own. And I'll have the answer key, of course, posted so you can check your answers before you take the test. As I go through these, I'm just going to kind of point the lesson that these come from, so you can always go back and check if you need to go back through the lesson after I've talked about it. Okay. So here we go. Number one, what I'll do is I'll do 1 through 5 because there are more 6 through 10 exact same types of questions. Okay. So question 1 is from lesson 1 and talks about the zero product law. Okay, so this is going to talk about the zero product law in that you already have two factored pieces set equal to 0. So all you have to do is T-chart and solve, okay? So you've already got your two factored pieces. This is like someone already did the factoring for you, and all you have to do is this part. So all you have to do is set each factor equal to 0. Okay, so x minus 3 equals 0, and 2x plus 7 equals 0. And then let's just get x alone. So as we know, with these here, it's a little bit easier when it's just an integer, an x minus or an x plus. Add that 3 to both sides, you get x equals 3. Notice the answer has the opposite sign of the value that was inside the binomial. Over here, to get x alone, there's a little bit more going on. So you subtract 7 from both sides of the equal sign, you get 2x equals negative 7, and then divide both sides by 2, and you get x equals negative 7 halves. And so now what I'm looking for is which of my choices has a positive 3 and a negative 7 halves. And of course, that would be choice B. Now, if you have an answer line provided, use it. The zeros of the function. Well, all that means is this is a 0. This is a Regent's way of asking that, right? So I'm just going to rewrite it right here. 0 equals x squared minus 4x minus 12. And this is, of course, lesson 2, where you already have standard form. You just now need to use the zero product law. So factor it and T-chart it. So what are the factors of 12 that will subtract to give me 4? Because it is a negative 12. Negative at the end means you're subtracting to get the middle. That would be 6 and 2. The bigger factor always has the same sign as the middle. And since the end term is negative, that means these are opposite signs. So opposite sign over there. And then, of course, T-chart. So x minus 6 equals 0, x equals 6. And x plus 2 equals 0, so x equals negative 2. Again, notice my answers, opposite signs of what's in the binomials. Okay, so positive 6 and negative 2. Again, choice B, because it's not 6 only. It's not negative 2 only. And had I factored with my signs incorrect, I might have gotten this part wrong. But I have my correct signs. We're good. Which of the following is equivalent to x squared minus 6x minus 27 equals 0? Well, that's a quadratic equation in standard form already. And notice all the choices are factored binomials. So all we have to do is factor this. Okay, what are the factors of 27 that will subtract to give me a negative 6? And that would be 9 and 3. 9 is the bigger factor, so it has to have the same sign as the middle. And since 27 is negative, this 3 has to have the opposite sign. So we're looking for an x minus 9 and an x plus 3, not necessarily in that order, but it just so happens that it is right here in choice D. So it didn't ask me to solve this time. I just wanted equivalent form. Okay, just wanted equivalent form. And that is still lesson 2. That's still lesson 2. Okay. Now this one is interesting. How many real solutions exist? Meaning, when I look at those 3 factors, how many places are going to give me answers for x? Is it 1 of those places? Is it 2 of those places? Is it 3 of those places? And the best way to ask this question is really to look at how many of those factors have an x involved. Okay, so this factor has an x, there's a solution there. This factor has an x, there's a solution there. This factor has an x, there's a solution there. So 1, 2, 3 solutions in this. If this GCF did not have an x attached, it would not have a solution. And that would mean this part didn't have a solution, only these. If there's only a GCF in a binomial, then there would only be 2 solutions as your answer. If your solutions, if 2 of your binomials are exactly the same, you'd only have 1 solution as your answer. Okay, so just giving you kind of the other scenarios. And of course, which of the following values of x solves the quadratic equation? Now this is lesson 3, you have to get standard form, you have to factor, you have to t-chart, you have to have your answers. So x squared plus 3x equals 4. First things first, subtract that 4 to be with the x squared and the plus 3x. And of course, since we need standard form, it's at the end. And now we think, well, what are the factors of 4 that are going to subtract to give me 3? Well, that would be 4 and 1, because my only other factors of 4 are 2 and 2. So it's got to be 4 and 1. 4 is the bigger factor, so it has to have the same sign as the middle. Since the end term is negative, this will have the opposite sign, which means that when I go t-chart and I set each factor equal to 0, I get opposite signs of what's inside the binomials as my answers. So -4 and +1 are my 2 answers, which is choice C. Okay, let me zoom out so you can see all of your multiple choices here. And again, the next page of multiple choices is just reiterations of these exact 5 questions with different numbers involved in the equations. Okay, so make sure you understand what I did with those. Notice that all of those were lessons 1 through 3. And now we get into the word problems, right? After the multiple choices, I believe there's one section where I just ask, straight up solve, right? So here we go. Hey, there we go. I was spinning the wrong direction. Let me solve 3 and I'll leave 3. I'll start with number 6 and I'll do number 7 and then I'll do number 10. Okay, how's that sound? Number 6, number 7, number 10. And then you do the rest. So 8, 9, 11 will be your practices. So number 6, I chose because I can see that it's a binomial set equal to 0, which means I only have 2 options for factoring, GCF or dots. So I immediately look for perfect square minus perfect square, and I do not see it. So that's GCF. What do they have in common as a GCF? X. Now I divide each term by x. I'm left with x minus 3. Each of those are my factors, so I set up a t-chart. X equals 0 and x minus 3 equals 0. And I solve the equations that result to get me answers. Well, this equation is already done. X is equal to 0. There's your answer. Over here, you do have to add 3 to both sides. You get x equals 3. So my two answers for number 6 are 0 and 3. Put them in the French curly braces. There you go. I chose number 7 because the instinct would be to subtract that x squared to be with the other stuff, right? But you need to keep that x squared positive. So we want to do the opposite of our instinct. We want to add that 14x to both sides and add that 40 to both sides. So we're adding 14x and we're adding 40. And we get x squared plus 14x plus 40 equals 0. So standard form is descending exponential order. Starts with your x squared, then your x term, then your constant equals 0. And the whole point of getting that equals 0 is so that you can then factor this trinomial. So what are the factors of 40 that are going to add to give me 14? So that would be 4 and 10. The bigger factor always has to match the sign in the middle, so 10 will be positive, but when your n term is positive, these two binomials have the same sign in them. So that also tells me that 4 is positive. And now I t-chart. So now it's x plus 4 equals 0. So subtract that 4 over, you get x equals negative 4. X plus 10 equals 0. Subtract that 10 over, you get x equals negative 10. And I always put them in French curly braces in order lowest to highest. Scooch. So you can see. Okay. But yes, your answers have to go in French curly braces. I am showing you the minimum amount of work required. You will lose points if you do not set your factor equal to 0 here. You have to apply the 0 product law. Okay, that's why we are doing the t-chart in the first place. You have to make sure you are applying that 0 product law yourself and saying, well, if this times this equals 0, then this is 0 or this is 0. That's where I get my answers from. All right, last one I'll do with you, and then you'll try the others. Number 10. I notice again I have a binomial, which tells me I'm either GCF or dots. I immediately check for perfect square minus perfect square, and this time I got it. So the factors of this will be 2 empty sets of binomials equal 0. The square root of 25x squared is 5x, so that goes in the fronts of my 2 binomials. The square root of 4 is 2, so that goes in the backs of my 2 binomials. And then I put different signs between. And if I have the exact same terms with the different signs between, when I FOIL, the middle has canceled out. That's what makes this perfect square minus perfect square. Now set each factor equal to 0. So bring down each factor, set it equal to 0, and now we need to get our x alone. So I'll start by subtracting 2 to the other side of the equal sign here. I get 5x equals negative 2. Well, to get x alone, I divide both sides by 5, because the opposite of multiplying by 5 is divide both sides by 5. I get x equals negative 2/5. And of course, fractions are rational answers, so leave it as is. No need to convert. Over here, start by adding 2 to both sides, and you should probably see a pattern, because then you're left with 5x equals positive 2, and divide both sides by 5. And what do you discover? Well, this is just the same fraction positive. They're opposites of each other. So there's 2 answers here, and since they are the same fraction but opposite signs, I can write them as plus and minus 2/5. There you go. So there'll be a couple just solves. You have to show all your work. Yes, your binomials have to be set equal to 0, or your factors set equal to 0 if it's GCF and binomial. Yes, you have to factor completely if that's the case. Yes, you have to show your factors set equal to 0, then show each factor set equal to 0, then give me answers for x, then state those answers at the end. Now we get to the word problems. And so there are 4 word problems. I will do 2 and leave you the other 2. Let's see, I've got basic number, I've got consecutive integer, and then I've got 2 shapes. You can handle basic number. I'll do consecutive integer and one of the shapes. So you handle 12 and one of the next two, I'll handle 13 right now. The product of two positive consecutive integers is 72. Find the integers. My guess is that some of you know the answer to this before I've even started. I know the answer to this before I've started. It's 8 and 9. But I've got to algebraically prove that. Okay? So only an algebraic response will be acceptable. So I've got to set up let statements. I've got to set up an equation. I've got to solve that equation. I've got to reject a negative answer. The product of two positive consecutive integers. Well, it gives me my let statements right here. So x is your first positive consecutive integer. And x plus 1 is my second positive consecutive integer. And since I want to product those, and my answer to that is 72, all I do is take x times x plus 1 and set it equal to 72. Now, distribute that x, and notice now we know where the x squared is. So now we know it's a quadratic equation. So we subtract that 72 over. So we get x squared plus x minus 72 equals 0. What are the factors of 72 that are going to subtract to give me 1? That would be 9 and 8. Bigger factor has to match the same sign as the middle, so that's a positive 9. Leaves me with a negative 8 because my n term is negative, so they had to be different signs in my binomial. And when I t-chart, notice I get x equals negative 9 and x equals positive 8. And I reject the negative 9. Why? Because my word problem told me I had to have positive consecutive integers. So I get to keep 8. And if I look, it's 8. 8 plus 1 is 9. What's 8 times 9? 72. This is a perfectly acceptable answer. Full credit right there. Full credit right there. Take note. Make sure you understand what I did. If you don't, ask me questions. Next and last, actually. Next and last. Who knew? Why don't I do 15? Because I think 14 is pretty basic. So 15, a contractor has 48 meters of fencing that he is going to use as a perimeter of a rectangular garden. Ooh, rectangle, rectangle, rectangle. Opposite sides congruent, opposite sides parallel, all angles 90 degrees. The length of one side of the garden is represented by x, and the area of the garden is 128. Let's see, area of a rectangle is length times width, and I know the area is 128 square meters. Determine algebraically the dimensions of the garden in meters. Well, wait a minute. A contractor has 48 meters of fencing he's going to use as a perimeter on the rectangular garden. I got to know perimeter first, don't I? Because the perimeter of this guy is 48. Let's see. Well, perimeter is 2L plus 2W equals 48. Well, let's see here. Length. If I know that, what if I get length alone and then I have the other one for width, right? So let's do that. Let's subtract this over. I get 2L equals 48 minus 2W. And then to get L alone, I just divide by 2. So I get L equals, both of these are divisible by 2, so let's do it. 24 minus W. So if my length is W. No, my length is 24 minus W. My width would be W. And those would multiply together to give me 128, right? Right. So let's try it. By the way, this is a tad bit harder than what would actually be on your test, but it's a good practice. I'm going to put these in standard form as I go. So W squared, it's negative W squared, excuse me. And then plus 24W equals 128. But I need that to be positive. So let's move these guys over. Positive W squared and minus 2W. 0 equals W squared minus 2W plus 128. Interesting so far. Okay, let's see. Well, 128, factors of 128, let's see. 128, oops. 128 seems like it would be divisible by like 4 and 8 and 64. 64, let's try that. Let's see how close we get. Oh, that's far off, right? So we got to get a little bit closer and let's think about some things. Oh, what about if it's divisible by 68? It's got to be divisible by 16, right? So 128 divided by 16 is 8. That's closer. Maybe 128 is divisible by 18? Nah. Pipe dream. Maybe a little bit lower, like a 12. 128 divided by 12? No. But I'm closer. Look, I've got that close to 2. Let's try 8. Oh, I already had that, right? 8 and 16. Not 12. What about 14? Oops. Oh, I was so close. Because it's negative and I'm adding to get the middle. Oh, that's not factorable. Ah, well. You know what? What we'll just do is stop there and zoom out. Okay, so sorry about that. We jumped up here because 15 is not factorable. So don't do 15 when you go to do this. Don't worry about that. That's a little bit more challenging than what's going to be on your test. Test is going to be those basic, the basic 13, 14, or excuse me, 12, 13, 14 word problems. Okay, so you'll be looking at one of each, one certain number, one consecutive integer, one rectangle on your test. Okay, make sure you're showing all your work and solving your word problems algebraically. Make sure you are indicating your work for your answers here. So if you get something wrong, maybe I can go and give you partial credit for your multiple choice. Use your white assessments packet as you work. Okay, so use this to get ready for your test. Okay, guys, this has been your Chapter 8 exam review. Chapter 8 exam is in Google Forms. Make sure you're practicing before your time to take that test. Okay, so that you're ready. See you guys soon.